Hello guys, in this video we are going to look at solving some equations which require the use of logarithms. So let's go straight into it. First example is going to be 2 to the power of x equals 3. Now, the first way in which we can look at it is like this. If you remember from the introductory video, we had that 2 to the power of something equals 3. And we think about it as, what is that power going to be? The logs will say that if you have log to the base 2 of 3, that should be equal to x. In other words, what we're saying is, to get from 2 to 3, you have to raise it by the power of x. And that's what it shows us. So that's one way in which you can do it. I'm actually going to show you another way in which it can be done. This way, although it seems longer, it might actually be easier in terms of following the steps. So, now that we know a little bit more about logs, here's what we can do. Let's take the logs of both sides. It can actually be any log, but just to be consistent, I'm going to say this. Remember, when you see log on its own, that means log to the base 10. Okay, so I have log of 2 to the x equals log of 3. All I've done is just taken log of both sides. Now what we can see is, on the left hand side, you've got log of 2 to the power of x. We can actually use our log law to rewrite this as x multiplied by log of 2, which equals log of 3. Now at this stage, to get x on its own, that's just going to be x equals log of 3 over log of 2. Right, and at this stage, I'm just going to type that into my calculator, so I can type in log of 3 over log of 2. So that gives me that x is equal to 1.58496 and so on, and to 3 significant figures, as the question asks, that's going to be 1.58. Okay, so now I'm going to look at another example. Right, let's take another example. Let's say 7 to the power of x is equal to 2. If you'd like, you can pause it and have a go. I'm going to do it now. So again, this is the last time that I'll show you the introductory way of doing it, and from then on I'm going to do it by the approach of taking logs of both sides. So I could say 7 to the power of x equals 2, therefore I have the x equals log to the base 7 of 2. That's one way of doing it, and you type that in your calculator, it gives you an answer. Now I'm going to do it like this. Take the logs of both sides. Log of 7x equals log of 2. Again, remember, log means log to the base 10. Again, using my power law, I have x log 7 is equal to log of 2. And then I have the x is equal to log of 2 over log of 7. And again, as I type that into my calculator, I will have log of 2 over log of 7, which gives me 0.356207, and so on. And to three significant figures, that is going to be 0.356. Okay, let's do some more examples. So let's take this example. Let's take 4 to the power of 2x is equal to 100. So taking the logs of both sides, I get log of 4 to the power of 2x is equal to log of 100. Using the power law, I get 2x log of 4 is equal to log of 100. And then I get, by dividing by log 4, I get 2x is equal to log of 100 divided by log of 4. And then, just dividing further by 2, I get x equals log 100 over, the 2 can also go in the denominator, 2 log 4. I'm just going to quickly type that into my calculator. Inputting that in my calculator, I get that x is equal to 1.66094 and so on. And to three significant figures, that's going to be 1.66. Okay. Now we're going to look at an equation where it makes more sense and it's probably easier to use the idea of taking logs on both sides. Okay, so this will be the next example. My next example is going to be 3 to the power of x is equal to 2 to the power of x plus 1. So what I'm going to do is take logs of both sides. I have log of 3 to the x equals log of 2 to the x plus 1. Now again, using the power law, this time on both sides, I have x log of 3 equals x plus 1 in a bracket times the log of 2. Now this looks a little bit more complicated, but actually it's just like solving a normal equation. I'll show you how. Let me just expand the right hand side. So I get x log of 3 equals x log of 2 plus 1 times log of 2, which is just log of 2. What I have is an equation effectively, and you've got x's on both sides, so I'm just going to get everything with x on one side and everything without an x on the other side. So I have x log 3 take away x log 2, which equals log of 2. On the left hand side, all I have to do now is just factorize x. So I get x, open bracket, log of 3 minus log of 2, which equals log of 2. And actually, I can just divide everything through by what's in the bracket. So I have x is equal to log of 2, all divided by log of 3 minus log of 2. I don't really need to bother with simplifying. I can just put it straight in the calculator. And if I type it in the calculator, I should get x is equal to 1.70951 and so on. And again, to three significant figures, that is going to be x is equal to 1.71. Okay, let's take another example that's like that. Let's take 5 to the power of 2 minus x is equal to 3 to the power of x plus 1. Okay, so again, take logs of both sides. I have log of 5 to the power of 2 minus x equals log of 3 to the power of x plus 1. Using the power laws, I get 2 minus x multiplied by log of 5, and that equals x plus 1 multiplied by log of 3. Again, expanding both sides, I get 2 log 5 minus x log 5 equals x log 3 plus log 3. And then, again, I'm going to get everything with x's on one side and everything without an x on the other side. So I am going to subtract log 3 from both sides, and then I'm going to add x log 5 to both sides. So I should get this 2 log 5 minus log 3 equals x log 3 plus x log 5. So just take a moment to really check that you understand that step. And then at this stage, I can just factorize on the right hand side. So I have 2 log of 5 minus log of 3, which equals x. Open up the bracket, I get log of 3 plus log of 5. Close off that bracket. And then, again, don't really need to bother with simplifying because I'm solving for x and the calculator can do all the work for me. So I get that 2 log of 5 minus log of 3, all divided by log of 3 plus log of 5 is equal to x. And again, typing that on a calculator, I get that x is equal to 0.78294 and so on. And to three significant figures, that is going to be 0.783. Okay, we'll look at some more examples that are a little bit more complicated in the next video. That's it for now.